Hey guys, I'm finally back. It's been a long time since I've had several days of decent imaging weather, but I've finally had some and have been able to evaluate several things that I had stacked up on the runway to look at. Um, the things I was looking at over the past couple of days during the good weather, I wanted to verify the mount tracking response after I made the second round of adjustments to the RA worm gear spacing. I had previously adjusted the worm gear spacing. It was too tight and I was getting significant binding every time a gear tooth interacted with the worm gear. So that was something I wanted to see if I had cured through my second round of adjustments. I had done a video a little while back of the Excelon USB 3 hub, and while I had used it with instruments operating, I had never used it during an imaging session, so I wanted to try that out during this recent good weather period. And something I'm really excited about, PhD2 has released a new version of their guiding software that includes predictive periodic error correction. Some time back, I did a video looking at the performance of pointing error characteristics based on a guide log analysis, and found that for my mount, a CGEM, there's quite a bit of mechanical pointing error that is not or cannot be handled by the original PhD2 guiding algorithm in the right ascension axis. Well, they have been busy updating that to include a what they call the Predictive PEC guiding algorithm, and I wanted to give that a try. Pretty excited about that. And I'm trying to simplify my process, so I wanted to compare the PixInsight pre-processing script results with the Nebulosity results. I currently use Nebulosity, but wouldn't mind scaling back to just rely on PixInsight completely. And so I wanted to share the results of that comparison with you. And finally, I've made some adjustments to my image grading workflow that I wanted to share with you in this process. So a couple of things to go over here. In the several nights that I had, and I'm going to take one night in particular, I collected the lights and the flats, the bias and the darks, etc., just like we always do. But in this case, rather than simply pre-processing them with Nebulosity, I also used the PixInsight pre-processing script, and then used the PixInsight subframe selector script to grade each of the the calibrated subframes, not the registered subframes, but the calibrated subframes, using the maximum full width, half maximum grading criteria that I describe in another video. And then we'll compare those results. Now, you'd think, given that we're using the same source data over here, and the lights and the flats, the bias, the darks, etc., that the comparison of the full width, half maximum is going to be dead on equal. Well, there's a very interesting and slight difference depending on how you pre-process the results, and we'll take a look at that. After that, I went and what I've been doing, this is part of the new workflow, I align all the subframes regardless of what the grading criterion is. I align all the subframes to a common reference frame, just as you normally would using the PixInsight image registration script. And here's something that's new for me. As a consequence of some of the work that I do during the daylight hours, I wrote a program that goes in and renames the aligned subframe files, but it appends the full width, half maximum grade for each of those files. So at a glance, I know what I know how good each frame is. We'll get into that a little bit farther into the presentation. And then I stack each of the frames, whether it came from Nebulosity pre-processing or PixInsight pre-processing, and we'll compare those two stacks. So that's what's on the slate for today's little presentation. This is an image from an analysis of the guide log from one of the nights. I think I had a good 4 nights of imaging there in sequence. But this is one of the nights. And basically, I started out looking at NGC 2683. I picked it up just when it was dark enough to do imaging right at the meridian, followed it down for a couple of hours, then switched over to NGC 4725 just as it passed the meridian, and followed it down for the remainder of the evening. I had balanced the scope, so I was doing the imaging on the west side of the meridian, and so the OTA was on the east side of the meridian, and I had balanced the setup so that it was a bit heavy on the east side as recommended. I think it's a good recommendation, and I did that here. And that's one reason I wanted to stay with imaging on the west side. I didn't want to image on the east side and then the west side and have to go out and change the balance, or be imaging with a balanced scope, but on the but with an improper imbalance, if you will. And so I kept with the theme of imaging on the west side, and just picked up targets as they came up to the meridian and then followed them down. Now, this little gap here is when I switched targets from 2683 to 4725, so that's understandable. And then these larger spikes that you see, including this guy over here, this guy over here, those represent manual adjustments that I made to the pointing to compensate for a little bit of drift that was going on due to probably imperfect polar alignment. But I was not imaging during those. But basically, what you see here is that for DEC, the blue line, I'm below 0.5 arc second RMS arc seconds, which is actually for me pretty good. And also in this first phase of imaging with the first target, the RA pointing error is also quite good. Now in the second, for the second target, the DEC performance was still about the same, performed pretty well. It got gradually worse as the night wore on, but no extreme deviations. The RA started out a bit worse than what it had been with the previous target, and like DEC, it got a little bit worse as the night wore on. But basically, I had the best pointing error, lowest pointing error when I was imaging near the meridian, and it got a little bit worse as I observed the target all the way until it was about 20 degrees off of the counterweight bar, was about 20 degrees off of vertical. What I'm not seeing here, and this is good news for me, I'm not seeing any evidence near the end when the counterweight bar is nearly vertical, and now I've lost nearly all the benefit of balancing the scope east heavy, because there's no east or west now, or very little of it. I'm not seeing any of that instability that I saw some time back. So I feel like these results at least confirm that whatever problems I've had with the free play, they seem to be at least mitigated enough that it's not adversely affecting my guiding. So I'm pretty pleased. I think what this is really saying is that the predictive PEC algorithm in the new PhD2 guiding software is actually doing a very good job. There's a limit to what it can do. I'm dominated here by seeing conditions, so the predictive PEC is going to handle mechanical sources of pointing error, not seeing, and so it's not going to help me with that. It will help me with a good bit of, but not all of, the mechanical induced pointing error. And as a result, though, I think it's doing a really good job. I am totally on board, totally pleased with this new guiding algorithm they have just introduced. Now, why am I seeing that gradual poorer performance? The pointing error tends to get worse as the night wears on. Well, I think part of the story, if not all of the story, is wrapped up in the guide star signal to noise ratio. When I was imaging that first target, I had there's a very nice bright star that's in the field of view for 2683 for my system, and I get a very high signal to noise ratio. After I switch to another target, I don't have the benefit of that really bright star. It's pretty good. The signal to noise ratio is pretty good, but as you can see, as the target tracks more and more towards the horizon, I'm looking more and more through the atmosphere, getting closer to sky glow from the horizon, my signal to noise ratio is reducing, and as a consequence, so is the pointing error. So the pointing error actually is tracking this guide star signal to noise ratio quite well. And what that's really telling you is, boy, if you can, find a guide star that gives you a significant signal to noise ratio up in the 25, signal to noise ratio of 25 or so, and that you'll be better off. So I'm certainly going to look for that in the future. Now let's look at the full width half maximum, or the maximum full width half maximum. In other words, that grading criterion from the PixInsight subframe selector script. It follows, this image is almost exactly what we saw for the pointing error that from the guide log analysis. It starts off at around 2.5, which is actually very good for me, between 2.5 and 3. For the first target, I switched to the second target, still near the meridian here, and I'm still within 2.5 to 3. And as I start to image more and more through more atmosphere, and I lose, my signal to noise ratio is dropping, both in terms of the guide star, but also in terms of the imaging target that that we're concerned about with this graph. I start to lose, the full width half maximum tends to grow. But this image here is telling me that full width half maximum is strongly correlated with point error, something we've talked about before, but therefore, particularly with the help of the new predictive PEC algorithm, we are now much more correlated with guide star signal to noise ratio. All things that we have a certain amount of control over when we do our imaging. Now, for something that's interesting, these values plotted here for the maximum full width half maximum are obtained from a set of data that was pre-processed using Nebulosity. What happens if we compare these data with the maximum full width half maximum obtained from the subframes as pre-processed with PixInsight? And here's what's surprising and interesting. First of all, at the 30,000 foot level, there's a strong correlation. In other words, the blue dots are falling very close to the yellow line that says, if they were all on, well, let's put it this way, if they were all on the yellow line, it would say it doesn't matter whether you pre-process with Nebulosity or PixInsight. But they're not all on the yellow line. And in fact, they're all a little bit below and to the right of the yellow line, which is saying that I get slightly larger full width half maximum values when I analyze frames pre-processed with PixInsight versus those pre-processed with Nebulosity. Now, essentially, what this data is saying that a Nebulosity pre-processed data they consistently produces smaller full width half maximum values than those obtained from PixInsight processed data. And that's a little bit surprising. I don't have a good explanation for that. I just note it in this case. And we'll come back to what the stacked images look like, because there's something else that popped out in that comparison that's a tad disturbing. But for now, let's go in and take a look at this procedure I'm using now for grading and then combining graded subframes into an integrated image. Okay, so here we are in a directory of a recent target, or a target I was looking at some time back. I've been going back through and regrading all of my subframes from previous sessions. But here's an example. This is M77. You can see in the directory here it's M77. If I go back up, these are the various dates that I imaged M77. We're taking a look at this date here. What I will do is go through, and the calibrated frames, these are the raw frames coming out from the Canon camera. Those are the calibration master frames there, and then this is the pre-processed frames using Nebulosity. You get a pproc prefix here when it's pre-processed, and a recon prefix after you've converted the black and white images and debayered them into a color image. So these are the color images that have been pre-processed. And so what I'm doing is using the PixInsight subframe selector script to analyze these frames for M77. So you notice that they're not aligned, they're not registered with a master frame yet. They're just the frames after pre-processing and converting into color images. So now what I've done is to write a program here that, well, let's back up. Here is the file from the subframe selector script. Notice that right here is the weighting expression. I have this this expression right here is the expression for the maximum full width half maximum. And again, that's discussed in another video, so I won't go through it here. This is the file name with the full path, and over here is the weight. In other words, this is the value calculated using this formula. This is the maximum full width half maximum. So I've written a program that goes in, reads this file, pulls out the file name, starting with, gets rid of all the directory structure information, pulls out the name starting with recon underscore pprog underscore etc. all the way out to .fit in this case, and it basically gets rid of the .fit and just gives me this file name and records this number here. Alright, so now we have those numbers. Now what I'm going to do is run the program. It's just a very simple console based application. This is not terribly user friendly. It's just intended for me to get stuff done. But I'm going to type in the name of that subframe selector script. So M77 B4 underscore 2017 -02 underscore subframe selector table dot CSV. And you see what it's doing. It's going through all the files that are in that table, and it's pulling out the file name here. It's doing it's adding an underscore r.xisf, okay, which is the registered frame. So it's pulling the grade from the pre-registered frame, but renaming the registered frame and adding on the 485 here, for example, is 4.85. In other words, a maximum full width half maximum of 4.85. I multiply by 100. And this way, when I rename these files this way, you can see what just happened. All the files are renamed, but now I can use the name sorting option in the Explorer window here, or the File Explorer window here, and I have all of the frames listed in the order of their maximum full width half max. One of the things you'll notice when you use the subframe selector script, you'll get some odd results from time to time. This is saying that the 57 says that the maximum full width half maximum was 0.57, which is ridiculous, of course. So I tend to ignore anything like that, anything that's very low, typically below about 2, or in this numbering system 200. And so the lowest probably legitimate full width half maximum value is 3.08. And then they're all numbered here in the order, and that way when it comes time to select these files for use in integration, then I can just select whatever I think. If I want to go up to a 3.5 maximum full width half maximum, then I can just select those values. I know exactly what they are right at a glance. If I want to be even more restrictive and select up to 3.25, well, I'm going to be pretty restrictive, and I may be stuck with those files. But that leaves a lot of files out. So there were a lot of cases here. And again, this is older data. This is not the data we were just looking at in the recent tracking exercise. This is old data. And in fact, what I'm finding out in my old data is I'm having to throw out quite a bit of my images in order to keep the full width half maximum below probably a reasonable number. But anyway, this is a simple use of a program I've written that renames the files, and now I have the grading result built into the file name for easy reference. Let's take a look at PixInsight. So now if I'm in the image integration script and I want to add files, I can move over to the M77 directory, and it's very easy here to just select those files that I want to select for integration. And now I know that I've selected files that have a full width half maximum less than 3.5. And if I want to go back and redo an integration based on a different criteria, well, that's easy to do. I can clear that, go back to the file list, again excluding those with the ridiculously low full width half maximum, come back in and select a smaller subset of files. So it's very easy to recombine the images using different grading a different grading criteria or limit in this case. And so that's what I've started to do as a matter of course now. Now let's get back to the data I recently collected and look at the stacked results for the Nebulosity pre-processed data. There's kind of a greenish blue or green tint to the data. This is NGC 4725. It's a very faint object, plus I was dealing with a good bit of moonlight. C'est la vie, that's just the way it goes. But here's the odd thing. Here's the same data pre-processed with PixInsight. Now I have a red tint. Now the first thing I thought is, well, it must be using the wrong Bayer matrix setup in order to convert into color, but checking the process results, it is using the correct. It's using the RGGB scheme for debayering these files, which is what it should be using for a Canon T2i. So there's a couple of things here that are a bit irritating. One, this red tint that I'm getting is color variation that I'm getting with the PixInsight pre-processed data, and two, that weird issue about the full width half maximum being somewhat smaller for Nebulosity processed data versus PixInsight processed data. So that was a bit of a surprising finding here. Now let's go back and summarize what we were looking at. All right, so what did we learn in this little imaging session? Well, first of all, I was very pleased for myself that the RA worm gear spacing adjustments that I made seemed to be successful. I'm not seeing the instability that I saw initially, nor am I seeing the binding that I saw after my first round of adjustment. I still feel like there's some free play, but it doesn't affect guiding, and if it doesn't affect guiding, then I don't care. I'll leave it like it is. It's a little too much trouble to make an adjustment and not know whether you're done there. So I'm going to call that a victory. The Excelon USB hub, I haven't mentioned it too much during this presentation, but for the first time I was able to use it during an imaging session. I had the mount, the guiding camera, and the imaging camera, all USB 2 devices plugged into it, as well as an external USB 3 hard drive. So they were all connected to the hub and then connected into the laptop through a USB 3 port, and that worked flawlessly. I didn't have any issues whatsoever. So all the issues I've had in the past of finding a hub that was sturdy enough to last and provided reliable results, I think I've finally found one that works for me. So I didn't have any issue with the controlling the mount, or with the imaging camera, or with the guiding camera, and transferring data and whatnot. So that's another victory here, and I'll be using that hub going forward. The first use of the PhD2 Predictive PEC algorithm is awesome. I think it's very successful. That's the best consistent guiding results that I've seen since I've had them out. I highly recommend it. If you haven't already, download the latest PhD2 developmental code copy version and give it a try. Now, if you have a mount if you have a $15,000 mount versus a $1,500 mount, you may not see much benefit. But for those of us with the CGEM and other similar type mounts, you might want to go ahead and download it. I think it's an outstanding improvement and update to the PhD2 code, so I highly recommend it. I think it works great. Got curious results, worse grading results, and then a red tint when I pre-processed the image data with the PixInsight pre-processing script versus Nebulosity. So at least for me, until I can figure out what the heck's going on here, I'm going to continue to pre-process my files with Nebulosity. And finally, I've updated a workflow by including grading results as a prefix into the file name of the registered frame. So the grading is done with the just the calibrated frames, but not registered. And then once they're registered, I rename those files with the maximum full width half maximum value that I'm using for grading subframes. This makes it very easy at a glance to see which frames are better than other frames. The bad news is, as I've gone back and revisited old data, I find that I've got just a ton of hideous, extremely poor images by the standards that I'm using today. So I've got to go back and re-image a number of targets to try to apply this new, better performing mount and better results in order to get better, and ultimately a better stacked image. So, you win some, you lose some. Anyway, I just thought I'd drop you guys a note with some of my findings on my recent time out outside, and be interested to see what your thoughts are, particularly on the PhD2 guiding algorithm, and if you have any thoughts on the what might be causing what I've found in the PixInsight pre-processing script. I'd be interested to hear anything that you might have to say there. Well, I'll sign off for now, and maybe I'll get a clear sky and be able to do some more damage later on. Talk to you later.